So I made a mistake whenever I created the foldable, and it says find an equation of the form y equals a sine bx that produces the graph below, and then I left the graph blank. So we need to draw in the graph. So on your axis, just put 4 tick marks, and then I want you to put 4 tick marks along the bottom here as well. And this graph was already supposed to be given to you. It's supposed to be part of the problem. So we're just sketching in the problem, basically. So put a point there, and this is 4, this is -4, this is pi over 4, and this is pi over 2. And just sketch in these points. One right here, one here, one here, one here. And then we're going to go backwards a little bit and also do one down here. And then sketch in a smooth curve. So sorry about that, but this is supposed to be your problem. So I'll do my work and everything, I guess, in pencil. So we need to find an equation of the form y equals a sine of bx that produces this graph. So first of all, we need to try to figure out what a and b are. That's basically, once we find a and b, we can write the equation. So to find a, it's pretty easy. Find a by looking, oh, you can't even see. Find a by looking at the amplitude. And here the amplitude is 4, so I'm going to say a equals 4. Okay, now we need to find b. How do we do that? Well, let's think about what b is. B is that thing that affects our period. Okay, so what we did before was we would take 2 pi, divide it by whatever b was, and we would get our new period length. So we're going to do that process in reverse now. So to find b, determine new period and solve 2 pi over b equals new period. Okay, so this is like our equation that we're going to be using. This one's easy. You just look at your amplitude of your graph. So let's set up that equation. Over here, my new period, to figure that out, we need to look at how far is it before it repeats. So it starts here, and then it repeats again right here. So you can see it does one full oscillation. So how long is this period? Well, it's pi over 2. So we're going to set up an equation like this. 2 pi over b equals our new period, which is pi over 2. So let's write that. 2 pi over b equals pi over 2. And now you just solve this equation. So I say just solve this equation, but let's make sure you all know how. This b is what we want to get by itself. So since it's in the denominator, we have to do a little finagling, I guess. Or, so there's 2 ways you can do it. You can multiply by b on both sides, then divide by pi over 2. That's one way. Or you can know how to work with proportions and cross multiply. That's the way I like to do, but I don't know if you guys all know how to do it, so I'm not going to take that shortcut. So multiply by b on both sides. So I have 2 pi equals pi over 2 times b. Now I'm going to divide by pi over 2, which is the same as multiplying by the reciprocal. So those all will cancel, and on this side I'm going to multiply by 2 over pi. And my pi's cancel. And so I get b equals 2 times 2, which is 4. So my amplitude's 4, my b is 4, so my equation for this graph would be y equals 4 sine of 4x. So why would you ever do this? Well, sometimes it's useful in real life. You get data about things and you plot out the points, and then you have to find the equation that matches it, that models it, and then you can use that equation for various things. So this is the most application that you're going to get when it comes to trig functions and graphing them, because in the real world you don't start with the equation. You start with the graph and the data, and you work your way to having an equation so that you can plug it into a computer and they'll do things for you. All right, so now let's move on to an example in our ISN.